Welcome. In this video, we will talk about XML and DB2 pureXML technology. This is the agenda for this presentation. If you need more information about this topic, you can refer to the Getting Started with DB2 Express, see ebook chapter 15 DB2 pureXML. Also the Getting Started with IBM Data Studio for DB2 ebook chapter 4, creating SQL and XQuery scripts. And for videos, you can go to db2university.com course lesson 11 DB2 pureXML. Let's start with a brief overview of XML and pureXML. So what is XML? XML stands for Extensible Markup Language. So it's a language that is designed to describe data. If you compare it to HTML, HTML is a language that describes how to display data, while in XML you actually describe what the data is. So that's basically the main difference between XML and HTML. Now XML is extensible. What that means is you could basically create your own language based on XML. So each of the tags, for example the tag called name or the tag called author, will mean something different depending on the context. Where you are using it, and we will talk later about XML schemas where you can establish some rules about these tags that you are using. Now XML is based on the hierarchical model. XML is flexible. You can add more tags as you need them. It is easy to share. Basically, you just need to create an XML document. You could use a text editor for this. It describes itself as we mentioned before. It's easy to extend. You can create more tags. It is vendor independent and it is platform independent. So you could develop or create XML documents in Linux, in Windows, Unix, the Macs, and so on. So at the top right corner you can see an example of an XML document. Now who uses XML? Nowadays it's been used by most industries like the banking industry, life sciences, retail, and so on. So what they have created is they have created their own language mainly for exchange purposes using XML. So for example, in financial markets you have XML, where that stands for financial information XML. So it's XML where the tags are appropriate to share financial information. Now in this slide we show you the different components of an XML document, and we are using in this case the serialized representation of an XML document. On the next slide we will show you another type of representation of an XML document. So in the serialized representation, we see at the top the first element, it's called the root element, and there must always be only one root element in an XML document. Inside the element we have subelements. We have the author's subelement, title, keyword, and within the author subelement we have other subelement as well, like author, what is inside. The tag is called an attribute. So in this example we have ID equals 47. So ID represents an attribute, and 47, which is in quote, is the value for the attribute. Now each element like authors, titles, keywords, and so on, they must have a beginning tag and ending tag. So there must always be matching beginning and ending tags. Inside tags you have the text node. So you can think of it as the data or the value that the tag is describing. Next on this slide we see the other way to represent an XML document, which is the Parsed-hierarchical representation. Now XML is a hierarchical data model, so a tree which is hierarchical in nature is good to represent an XML document. So in this representation we have a document node at the top, and then the element nodes represented in rectangles, and you can see basically it's a tree representation of the same document that we saw before in the previous slide. Now, XML document can be well formed and they can also be valid. What is the difference? Well, a well formed document is basically a document that satisfies the rules that are shown in this slide. So it must only have one root element. Each element has to begin with a start tag and end with the end tag. So they must have matching start and end tags. An element, other elements, attributes, or text nodes, and attributes must be enclosed in double quotes. Text nodes, they do not have to be, or they cannot be enclosed in double quotes. So the basic rules for a well-formed XML document. Now in DB2, you can only insert well-formed documents into the database. If they are not well-formed, you will not be allowed to insert them. On the other hand, we have a valid XML document, and a valid XML document is both it is a well-formed XML document and it is a document that is compliant with the rules defined in an XML schema document, or a DTD document type definition document. So basically, as I mentioned before, an XML schema is an XML document that contains some rules about your XML tags. So for example, let's say you have a tag called telephone. So in the XML schema document, you can specify that telephone can only include digits, and let's say can only include digits from 1 to 5. So these types of rules are stored in a XML schema, and a valid XML document would be a document that is well formed and also that satisfies all the rules that are in this XML schema. In the past, we used to use document type data definition documents, or DTDs, to do the same thing, to provide the rules for your XML document, but nowadays XML schema is what most people are using. Now in this case of DB2, an XML document does not need to be validated to be inserted into the database. That is optional. Alright, now let's move on and provide the definition. Or an explanation of what pure XML technology is. Okay, so what we have here is a very simple architecture of a relational database management system, where you have a relational engine. You use the XQL language, and through the relational engine you can access your data that is stored in tables. Now because of Web 2.0 and so the usage of XML has grown exponentially. So at the top right corner you can see a very simple XML document, and what many vendors did is they said, well, we have already database technology that has been used for more than 20 years. It's very robust, so why don't we just continue using this relational databases but modify them so they can store XML documents? So many of these companies, relational database companies or software companies, what they did was they decided to do some mapping where the XML document would be mapped to tables. So in this example, different elements like name and phone would become columns, and the attribute ID would also become a column, and the name of the table in this example would be employee, which is the root element in this particular example. Now whenever developers had to use XQuery, which is the language used to navigate an XML document, in this scenario, since there was only a relational engine available behind the since these software companies had to kind of do some mapping between XQuery and SQL, so that the XQuery that is transformed to the SQL could be understood by the relational engine, because the relational engine could only understand SQL, and that's how they could access their data, which was stored as a table, because as shown before, the XML document was mapped to tables. Now, in the case of IBM DB2, we took a different approach and we basically created this technology that we call pureXML technology. The way it works is based on two characteristics. So the first one is we actually develop a second part of the engine to handle XQuery to understand XML, and then for the XML document, we are not mapping it or converting it to a table. We actually parse this XML document and convert it into a tree. As said before, a tree is hierarchical in nature, so we are keeping the hierarchical structure of XML documents, and that's how we are storing it in the database. Now, if a developer issues an XQuery statement, we can directly go through the XML engine that understands XQuery and then go directly as well to the data, which was also stored as a tree, so there is no mapping at all in this case, and therefore the performance will be a lot better. So the processing format is equal to the storage format. Under pure XML, another thing to note is that the relational part of the engine and the XML part of the engine can talk between each other, so therefore you can have some sort of integration between relational data and hierarchical data. So for example, let's say I'm a medical researcher and I'm trying to find the cure of cancer, so I have created this table called patients where I have several columns. Some of them are relational, some of them store XML. So the first 5 columns are relational columns, like the name, sex, age, coffee means how many years this patient has been drinking coffee, smoke means how many years this patient has been smoking, and then the DNA column is the column that has been created with the type XML, so it's used to store XML data. So we choose to store DNA information using XML because XML is good to store unstructured information and DNA is unstructured type of information. So in this table we have relational data and XML data, and we want to do some integration that allows me to run some queries, and based on the results of those queries I can establish some relationships, maybe between a factor like drinking coffee for more than 10 years or smoking for more than 20 years, and then appearance of, let's say, a gen with a value of 987. So how can we do this? Well, we could run a query like this, and we will cover this in more detail a little bit later on the other videos. But over here what we see is that we have an SQL statement combined with some sort of an XML function. So the first 2 rows and the best 4 rows for this query are just SQL as usual. We have a select statement with a where clause, and we have several filters using the relational columns. The third and the fourth rows are what we call a SQL XML function, and this function that we are using in this example is called XML exist. So using this function I will be able to go down a given path. Let's start with the first character here. So we have $P, dollar means it's a variable, and where is this variable P defined? It's defined on the 4th line where it says passing patient's DNA as P. So if you recall from the previous slide, patients of the table, the DNA is the name of the column that contains my XML document. So basically I'm passing to variable with the XML document. Now that I have my XML document, I'm pointing at the root. I'm going to go down to the patient element, and then I'm going to keep going down to the medical detail element, and from there the square brackets mean it's like a where. It's like saying where gen x equals 987. So basically I'm using this function to add another filter. So to this query, but this filter is based on an XML element with a value of 987. So by running queries like this, I could get some indication of relationships between factors like coffee and smoking and the appearance of a given gene which maybe appears in most cancer patients. Now in this slide, we just show you that when you go from the Parsed-hierarchical representation to the serialized representation, this process is called serialization, while when you go from the serialized representation to the Parsed-hierarchical representation, this process is called XML parsing. On this next slide, we provide a little bit more of detail as to how we store XML in database. So we simply create a table as usual. In this case, we have created a table department, and we have a relational column like dep id, but then at the end we have another column called dep doc, and we're using the data type called XML. So that's the data type that is required when you want to store XML documents, and it does not have to be the last column in the table. It could be anywhere that you can define this data type.